Welcome all of you to this video. Today in this video, we will learn about the concept of circumference of the circle and area of the circle. As you all know that, the group of all the points on a plane which are at a constant distance from a fixed point on the plane is called a circle, whose area is pi r raised to the power 2. Have you ever wondered how this formula for area would have been derived? Come, let's try to understand it. It is a circle with radius r. If the circle with radius r is filled with the inner circles of radius r1, r2, r3, etc., then we see something like this. Come, let's consider one more circle. If we now cut this circle from one of the parts and then straighten it, what we get is a straight line, which is the circumference of circle, that is, its perimeter. So if we cut this group of circles from here and straighten it, what we see is something like this. Here, you can see that the outer circle is the base of this shape and other inner circles are also located here respectively. Can you tell what will be the length of the base of this shape? Absolutely correct. Its length will be 2 pi r because it is a line made of the outer circle, which is what we call as the perimeter of the circle. But can you tell the value of circumference of a circle, how 2 pi r is determined? Absolutely correct. Since we know that the circumference of a circle and its diameter has a constant ratio, which is represented by pi, and by solving it, we get the circumference of the circle. And the height of this shape is nothing else but the radius of the outer circle, which we present using r. Observing this shape carefully, we can say that this shape is a triangular one. So can you tell how we can find the area of this triangular shape? Well done! Since we know that the area of a triangle is 1 upon 2 multiplied by the base multiplied by the height, therefore, in the area formula, on putting the value of base and height of this triangle and solving, we have the area of the triangle pi r raised to the power 2, which will be equal to the area of the circle. So you must have understood that how the area of the circle as pi r to the power 2 is determined. Can you draw these circular objects around you and find their area? If we trace these objects on a paper, we can easily find their areas. In this video, we studied about the circumference and area of the circle. In the next video, we will see some interesting examples based on this. Welcome all of you to this video. In the previous video, we studied about the circumference and area of the circle. Today in this video, we will see an example based on this. Raj is going to school on a bicycle, where the cycle wheels rotate 210 times per minute. If the diameter of the wheel is 56 centimeters, can you tell at what speed per hour Raj is going? Come, let's try to solve this. We see that the speed with which Raj is cycling per hour is the distance traveled by the cycle in one round. Therefore, we can say that the distance traveled by a wheel in one round is equal to its circumference. But we do not know the value of its length, that is, its circumference. So, can you find the perimeter of the wheel? Since we know that the circumference is equal to 2 pi r, where value of pi is 22 upon 7, r is the radius. But here, the value of r is unknown. So let's find the value of r. We learned in our previous class, half the diameter is the radius. Therefore, dividing the diameter of the wheel by 2 gives us 28 centimeters as the radius of the wheel. By putting it in the circumference values, that is, in equation 1, we get the circumference of the wheel as 176 centimeters. So, we can say that the wheel covers a distance of 176 centimeters in one round. So, can you tell how far it has covered in 210 rounds? Well done. Raj has covered a distance of 36,960 centimeters, that is 369.6 meters. Since we are given that wheels rotate 210 in a minute, therefore, the distance traveled by the wheel in 1 minute is equal to the distance traveled in 210 rounds. So now, can you find the speed per hour of Raj? Absolutely correct. Its speed in kilometers per hour. Because we have to find the speed per hour, we also multiply by 60. On solving this, we get 22.176 km per hour. So we can say that Raj is going at a speed of 22.176 km per hour. Today in this video, we solved an example with the help of the circumference and area of the circle. In the next video, we will see what common mistakes are made while solving these type of questions. Welcome all of you to this video. In the previous video, we solved an example with the help of the circumference and area of the circle. Today in this video, we will see what common mistakes can be made while solving these type of questions. Tina is walking on a circular path of 7 meters, which is outside the circular park. If the radius of the park is 18 meters, what will be the area of the path? Which of the following answer is correct? Pause the video to solve the question and then match your answer. Come, let's discuss option 3. Since it is given that Tina is walking on a 7 meters circular path which is outside the park, so we can say that this circular path and the total radius of the park, that is r, will be 25 meters, which we would have displayed from this circle. So can you find the area of the path from this? Come, let's see. First, we find the area of the whole circle, which is represented by equation 1. Similarly, find the circle with area of the park, which is represented by equation 2. Since we have to find the area of the path, so subtract from equation 1 the equation 2. Which, when solved, gives the area of the path as 946 square meters. So, option 3 is the correct answer. If you have selected option 1, it was a good try. But it was the wrong answer. Because when you have to find the area of the path, then you consider the width of the path as the radius itself and solve on the basis of it. Because of that, your answer gets wrong. If you have selected option 2, it was a good try. But it was the wrong answer. Because here, you are not finding the area of the path. Rather, the area of the circle by the total radius of the park and the path. Which is why you get the wrong answer. Often children make such mistakes where they are unable to find the radius or diameter of the circle and determine the wrong area. Let's look at another example. Ramesh fences in his circular field. The cost of fencing is 15 rupees per meter, the total expenditure of which is 3,960 rupees. If he needs to plough his field, he will have to pay 50 paise per square meter. Then, can you tell how much money he will have to pay for ploughing the entire field? Which of the following answer is correct? Pause the video to solve the question and then match your answer. Come, let's discuss option 1. It is given that the total cost of the fence at the rate of 15 rupees per meter would be 3,960 rupees. This means that the total length of the fence is 264 meters. So now, can you find the radius of a circular field? Absolutely correct. To find the radius, we will take the help of the formula of circumference of the circle. Which, when solved, gives a value of radius that is 42 meters. Since we have to find the total expenditure in ploughing the field, for which we will need the area of the field, solving the value of r in the formula for the area of the circle, the area of the circle, that is, the area of the field, is 5,544 square meters. Because we know that the ploughing of the field is 50 paise per square meter, so to plough the field, Ramesh will have to pay 2,772 rupees. Hence, option 1 is the correct answer. If you have selected option 2, it was a good try. But it was the wrong answer. Because to find the radius of the circle, you use in the formula of circumference d instead of 2r. and assume the value of d as the radius, that is, the value of r. And let's solve further on the same basis. That makes your answer incorrect. So hopefully you must have understood why the first option is right and the second option is wrong in this example. Teachers can also test students' understanding in class with the help of some such examples. Welcome all of you to this video. In the previous video, we studied about the circumference and area of the circle. Today, in this video, we will be studying about the concept of the area of a sector of a circle. Here some circles are given. Can you determine the area of all of these? Well done. We find the area of all these circles with the help of the formula of the area of the circle. Let us consider one more circle. If we divide the circle into two parts, what will be its area? Correct. If the circle is divided into two, then it becomes what is called a semicircle, each of whose area can be found with the help of 1 by 2 pi r square. You must remember that the center of the circle has a 360-degree angle. So can you now tell how many degrees will be at the center of a semicircle? Absolutely correct. Half of 360 degrees, that is 180 degrees. Let's move the discussion forward. What do you understand by the shaded part of this circle? Well done. We had studied in the previous class that the part of the circle surrounded by two radii and corresponding arcs is called the sector of that circle. Hence, in this circle, the area OPMQ is minor sector and the remaining circular region is major sector, where PMQ is the minor arc and PLQ is the major arc. So now, can you determine the area of minor sector OPMQ? Come, let's see. Assume in minor sector radius to be r and angle POQ be theta degrees. Now we know that at the center of the circle, the sum of the total angles is 360 degrees, so its degree measure is 360. Hence, the area of the circle can be considered as a sector whose area is pi r square. Similarly, when the degree measure of the angle at the center is 1, the area of the sector is determined to be pi r square upon 360. So can you tell when the angle at the center is theta, what will be the area of the sector? Absolutely correct. The area of the sector OPQ is theta divided by 360 multiplied by pi r square, with which we can determine the area of any sector. If you are now asked to determine the area of the part other than the small sector, that is, the major sector OPLQ of the circle, so can you determine the area? Come, let's see. Observing the figure carefully, we can tell that from the area of the circle pi r square, subtract the area of the minor sector. Then what we get is the area of major sector OPLQ. In this video today, we studied about the concept of the area of a sector of a circle. In the next video, we will see some interesting examples based on this concept. Welcome all of you to this video. In our previous video, we studied the formula of area of a sector of the circle. Today, in this video, we will see some interesting examples based on this concept. Madhu wants to distribute the cake on her birthday among her 6 friends if the diameter of the cake is 12 centimeters. Can you determine what will be the area of each piece of cake? Come, let's try to solve this question. Since according to the question, the cake has to be divided among 6 friends, so we can say that there will be total 6 parts of the cake, that is, 6 sectors will be formed, which we can demonstrate like this. Can you tell what will be the angles subtended by these sectors at the center? Absolutely correct, because we know that the sum of the total angles at the center of a circle is 360 degrees, and we are dividing the cake into 6 sectors, so the angle subtended by each sector at the center would be 60 degrees. Since we have to find the area of each piece of cake, that is, the area of each sector, so for the area formula of the sector, we need the radius. Now by assuming the value as r, we get the radius as 6 from the diameter of the cake. In the above formula, by putting the value of theta and r and solving it, area of the sector is found to be 18.85 square centimeters. And we are dividing the cake into 6 sectors. So, we can say that the area of each piece of cake will be 18.85 square centimeters. Let's look at another example. There is a disc whose radii are 14 centimeters and 7 centimeters, and the angle subtended by both sectors at the center is 30 degrees. So, can you find the area of the shaded part of the circle? Come, let's see. First, let's name the disc according to the given information. Let A1 and A2 be the areas of sector OAB and OPQ respectively. So can you determine the value of A1? Absolutely correct. Put the value of theta and r in the area formula of the sector. On solving, the value of A1 is 51.33 square centimeters. Similarly, the value of A2 is obtained as 12.83 square centimeters. Since we have to find the area of the shaded region, so we subtract the area of A2 from the area of A1, thereby giving the area of the shaded area 38.5 square centimeters. So we can say that the area of shaded part APQB is 38.5 square centimeters. In this video, today we saw some interesting examples based on the sector of the circle. In the next video, we will see what common mistakes occur while solving these types of questions. Welcome all of you to this video. In the previous video, we saw some interesting examples based on the area formula of the sector of a circle. Today, in this video, we will see what common mistakes occur while solving these type of questions. The length of the minute hand of a clock is 10 centimeters. The minute hand moves from 4:20 to 4:40 minutes. Can you now find the area covered by the minute hand? Also, find out what will be the area of the remaining portion left on the clock. Here, use the value of pi as 3.14. Pause the video to solve the question and then match your answer. Let's discuss option 1. We know that the angle formed by the minute hand in 1 minute is 6 degrees. And here it says that the minute hand moves 20 mark to 40 minutes, which means that it covers a total of 20 minutes. So the angle made by the minute hand in 20 minutes would be 120 degrees. This diagram shows the minor sector of a circle. By solving for the area of minor sector, putting theta and r in the formula, the area of minor sector obtained as 104.66 square centimeter. We see that apart from minor sector, we have the area of major sector left. Let A be the area of the major sector, to determine the value of which, from the area of the whole circle, the area of minor sector is subtracted. On solving this, the value of A found to be 209.33 square centimeters. Therefore, we can say that the area of major sector will be 209.33 square centimeters. Hence, option 1 is the correct answer. If you have selected option 2, it is a good try. But that is the wrong answer, because when you find the area of the major sector, that is A, then the value of theta is put as 240 instead of 120. Because in place of the minor sector, you considered the remaining angle. And forget that you have to subtract the area of the minor sector from the total area, for which you have to take the value of theta as 120 degrees only. But you did not do that, due to which the value of A derived by you is 104.66 square centimeter, which is incorrect. If you have selected option 3, it is a good try. But this is also the wrong answer. Because since without finding the value of angle of the minor sector as 120 degrees and put the value of angle as 20 degrees in the formula of the area of the sector and solve it further, which gives the incorrect value of the minor sector. And on the basis of that, you also determine the area of major sector, because of which your answer is incorrect. So hopefully you must have understood why the first option is right in this example and why the others are wrong. Teachers can also test the understanding of students in the class with the help of some such examples. Welcome all of you to this video. In the previous video, we studied about the area of the sector of a circle. Today in this video, we will study about the area of the segment of the circle. As you know, that a chord divides the circle into two parts, in which one part is bigger and the other is smaller, where larger part PSQ is area called the major segment and smaller part PRQ is called the minor segment. Come, let's find the area of the minor segment PRQ. For this, from the center O to the chord PQ, draw radii OP and OQ, where the value of angle POQ assumed to be theta. Observing the figure carefully, we can say that the area of sector OPRQ is equal to the sum of areas of segment PRQ and triangle OPQ. Since we have to find the area of the shaded region, so from the area of the sector OPRQ, area of triangle OPQ is to be subtracted, which is represented by equation 1. For the area of a triangle, first the base and height have to be found. For this, we draw on PQ a perpendicular OL, which makes triangle OPL congruent to triangle OQL, and from the corresponding part of congruent triangles, that is CPCT, we determine that angle POL is equal to angle QOL. The value of angle POL and angle QOL is theta divided by 2. In equation 1, the formula of area of sector is theta upon 360 multiplied by pi r square. And the area of a triangle is 1 upon 2 multiplied by base multiplied by height, where the base is PQ and the height is OL. Now if we talk about triangle OLP, we know that cos theta upon 2 equals to OL upon OP. From this, we get the length of OL as r cos theta upon 2. Similarly, the sin theta upon 2 will be equal to PL upon OP, from which the value of base, that is, PL, is found as r sin theta upon 2. That is, we know that in the triangle OPQ, the value of base PQ is twice that of PL. Hence, the value of area of triangle OPQ is r square multiplied by sin theta upon 2 cos theta upon 2 is what we find. By placing the above values in equation 1, the shaded part area of the segment PRQ, r square multiplied by theta upon 360 times into pi minus sin theta upon 2 into cos theta upon 2 is what we get. In this video today, we learned about the area of the segment of the circle. In the next video, we will see some interesting examples based on this concept. Welcome all of you to this video. In the previous video, we studied the area of the segment of the circle. Today, in this video, we will see interesting example based on this concept. In a circular garden, plant flower beds leave a hexagonal part of a circle. If the diameter of the garden is 40 meters, find the area of that part of the garden in which the flower beds are planted. Come, let's try to solve this. As you can see from the figure that there are 6 flower beds in the garden. According to this figure, there are 6 segments in the circle. Since it is given that the diameter of the garden is 40 meters, therefore, the radius of the garden will be 20 meters. So, we can say that the angle subtended at the center by each sector will be 60 degrees, which is represented as follows. Let's now talk about triangle AOB. Here we can see that OA is equal to OB, so the angle OAB and angle OBA will be equal. But can you tell what will be the value of angle OAB or OBA? Absolutely correct, since we know that the sum of all angles of a triangle is 180 degrees. Therefore, the value of angle OAB or OBA will be 60 degrees. So, we can say that triangle AOB is an equilateral triangle with all sides equal. Since we have to find the area of the segment, therefore, from the area of sector OAPB, the area of equilateral triangle OAB will be subtracted. In the formula of area of the sector, when values of theta and radius are placed and solved, the value of sector OAPB is found to be 209.52 square meters. While the area of the equilateral triangle, putting the value of the sides as 20 gives the value of triangle AOB as 173.2 square meters. On solving which, the area of the segment APB is 36.32 square meters. That is, the area of each flower bed is 36.32 square meters. Therefore, we can say that the area of the total flower beds is 217.92 square meters. In this video today, we saw an interesting example based on the area of the segment. In the next video, we will understand another interesting example in depth. Welcome all of you to this video. In the previous video, we saw an interesting example based on the area of the segment. In this video, you will see another interesting example based on this concept. In a given circle of radius 14 centimeters, XY is an arc of the circle, which forms a right angle at the center of the circle. So can you find the area of minor and major segment? Here, use the value of pi 3.14. Pause the video to solve the question and then match your answer. Come, let's see. the formula for the area of the minor segment is R2 multiplied by pi upon 360 into theta minus sin theta by 2 into cos theta by 2. According to the given information, on putting the value of theta in R, that is, radius in the formula, and solving, the area of the minor segment is obtained as 55.86 square centimeters. Since we have to find the area of major segment along with area of minor segment, so can you find the area of the major segment? Absolutely correct. For this, from the area of the circle, the area of the minor segment is subtracted, where the area of the circle is 615.44 square centimeters and the area of the minor segment is 55.86 square centimeters. On solving which, the area of the major segment is obtained as 559.58 square centimeters. So, we can say that the area of the minor and major segments in the circle are 55.86 square centimeter and 559.58 square centimeter. So hopefully, you must have understood how we can solve these questions easily with the help of the segment area formula. Teachers can also test the understanding of the students with the help of such examples.
Welcome to this video. In the previous video, we learned and understood about the area of a segment. Today, in this video, we will study about the areas of combinations of plane figures. Here, you are given some plane figures. Can you find the area of all these? Yes, we can find the area of these figures with the help of their formula. You all must have seen many figures around you, such as the design of windows, table covers, design of doors, gardens, etc. All these figures are composed of a combination of plane figures. Let's see some similar examples of plane figures. If the length of the rectangular portion of the window shown in the picture is 8 feet and the width is 6 feet, then can you find the total area of the window? Come on, let's discuss on this. First, let's make a rough figure of the window which looks like this. Looking at the window carefully, we can say that the upper portion of the window is semicircular and the lower portion is rectangular, where the length of the rectangular portion is 8 feet and the width is 6 feet. So, substituting the value of the length and the width in the formula for the area of a rectangle, on solving, the area of the rectangular portion is obtained as 48 square feet. Since we have to find the area of the whole window, we will have to find the area of the upper portion of the window, that is, the semicircle. Can you tell what will be the area of the semicircle? Absolutely correct. Its area is equal to 1 by 2 pi r square. But if we do not know the value of r, that is, the radius here, so let's first find the value of r for this. Observing at the shape of the window carefully, we can find that the diameter of the semicircle represents the width of the window. And we know that the diameter is twice the radius, for which we can say that the radius of the circle will be 3 feet. Hence, placing the value of r in the formula for finding the area of a semicircle and solving, we obtain the area of the semicircle, that is, the area of the upper portion of the window, which is 14.14 square feet. If we add the areas of these two figures, then we get the total area of these as 62.14 square feet. From this, we can say that the total area of the window is 62.14 square feet. Today, in this video, we found the area of a figure made by the combination of plane figures. In the next video, we will see some more interesting examples based on this. Welcome to this video. In the previous video, we saw interesting examples based on the areas of combinations of plane figures. Today, in this video, we will see some interesting examples based on it. ABC is a right-angled triangle, where the measure of angle B is 90 degrees. AB equals 28 centimeters and BC equals 21 centimeters. And semicircle with diameter AC and a quadrant of a circle with radius BC are drawn. Can you find the area of the shaded portion? Come on, let's see. By looking at the given figure, we can say that this figure is formed by the combination of three plane figures, a triangle, a semicircle, and a quadrant of a circle. Since we have to find the area of the shaded portion, we subtract the area of the quadrant of a circle from the sum of the area of the triangle and the area of the semicircle to get the area of the shaded portion. So, let's first discuss the semicircle with diameter AC. To find the area of the semicircle, we need to know its radius. But this is not known to us. So let's find the value of the radius. Looking at the figure carefully, we can say that the diameter AC of the semicircle is the hypotenuse of the right-angled triangle ABC. Therefore, using the Pythagoras theorem in the right-angled triangle ABC, we get the value of AC as 35 centimeters, which is the diameter of the semicircle. So, we can say that the radius of the semicircle is 17.5 centimeters. Substituting the value of the radius in the formula for calculating the area of a semicircle and solving, the area of the semicircle is obtained as 481.25 square centimeters. Now, if we talk about the area of right-angled triangle ABC, then, by substituting the values of BC and BA in the formula for calculating the area of a triangle, we get 294 centimeters square. So, now can you tell what will be the area of the quadrant of a circle with radius BC? Correct. Substituting the value of the radius as 21 centimeter in the formula for the area of the quadrant of a circle and solving, its area is obtained as 346.5 centimeters square. Since we have to find the area of the shaded region, substitute the value of these three areas in equation 1 and solve. The area of the shaded region is obtained as 428.75 square centimeters. Did you see how easily we solved this question with the help of different formulas? Today, in this video, we saw an interesting example based on the areas of combinations of plane figures. In the next video, we will understand another interesting example carefully. Welcome to this video. In the previous video, we saw interesting examples based on the areas of combinations of plane figures. Today, in this video, we will discuss another interesting example. In the given figure, ABCD is a trapezium, where AB is parallel to DC and the measure of angle BCD is 60 degrees. If cbfe is a sector of a circle with center C and the measure of AB and BC is 7 centimeters and the measure of DE is 4 centimeters, then what will be the area of the shaded region? Pause the video to solve the question and then match your answer. From the figure here, we can see that CE will be equal to CB because it represents the radii of the circle, the measure of which is 7 centimeters. Therefore, we can say that side CD will be equal to the sum of the measures of the sides CE and ED. Looking at the figure, we can say that the shaded region is obtained by subtracting the area of sector CBFE from the area of trapezium ABCD. Can you find the area of trapezium? Come on, let's see. From the formula for the area of a trapezium, we can see that we need the height of the trapezium. For this, we draw the perpendicular BL from point B on the side CD. Now, we get a triangle CLB where the angle at point C is 60 degrees. Hence, the height of the triangle CLB and the trapezium, that is, the measure of BL is obtained as 6.06 centimeters. Hence, substituting the values of AB, CD and BL in the formula for the area of a trapezium and solving, we can find the area of trapezium ABCD, which is 54.54 square centimeters. Let's now focus on the sector CBFE. Substituting the value of theta as 60 degrees and the measure of radius as 7 cm in the formula for the area of a sector, we find the area of the sector CBFE as 25.67 square centimeters. Since we have to find the value of the area of the shaded region, we subtract the area of the sector from the area of the trapezium. The area of the shaded region is obtained as 28.87 square centimeters. So, we can say that the area of the shaded region in the trapezium ABCD is 28.87 square centimeters. So, hopefully you must have understood how in this example we found the area of the shaded region of the figure formed by combination of plane figures. Teachers can also test the understanding of students in the class with the help of some such examples.